All right, let's find the antiderivative of this function right here that also satisfies this condition. So we are looking for a function whose derivative is e to the 7x. And again, we're not formalizing this process yet. We're going to do that soon. Right now, we're just kind of playing a guess and check game. So you might say, okay, I know that the derivative of e to the 7x is 7e to the 7x. That extra 7 comes from a chain rule, but we don't want that 7 there. So we can divide both sides of this equation by 7 and come up with the formula that the derivative of 1/7 e to the 7x is e to the 7x. That gives us the first term in our antiderivative. Then, if we look at the second term here, I'm going to change this 1.5 into a 3/2. And we're looking for the function whose derivative is 3/2 x squared. Well, this is a polynomial term, so we can use this formula right here. If we want to find the antiderivative of x squared, what we do is we raise the power on x by 1. That would be x cubed. And then we divide by that same power. Of course, we had this 3/2 out in front too, so we're just going to keep that there. So this is what we came up with. The antiderivative of 3/2 x squared is 3/2 times 1/3 x cubed. And I think that makes sense. Now we can simplify this, of course. These 3's cancel and we have a 1/2 x cubed. And that is going to be the second term in our antiderivative. We put a plus c on there because that then creates a family of antiderivatives. And I think we're in pretty good shape so far. The last thing that we need to do is satisfy this initial condition right here, which says that f of 0 has to be 8. That's capital F of 0 has to be 8. So that just means if I plug in x equals 0 into this function, I should get 8. Well, let's see what we get. Well, plugging in x equals 0 gives me 1/7 e to the 0 is the first term. Anything to the 0 is 1, so this is 1/7. Then we get minus 1/2 times 0 plus c. And we know that that has to turn out to be 8. So this means that we have an equation that we can solve for c, which will give us one specific value of c that will give us an antiderivative of this original function that also satisfies this condition. Okay, so if we subtract 1/7 from both sides here, that's going to be 56/7 if I'm not mistaken, minus 1/7, that's 55/7 for c. And our final answer is going to come from this line right here. The antiderivative of this function here that also satisfies this condition should be this right here. And we could check this answer by taking a derivative and making sure we get back the original function. We could also plug in x equals 0 and make sure that we get 8. But all that is going to work out, and we are done.